Rian and I am a student of the Indian High School Dubai. What you can see here is the basic model of a working hydroelectric turbine. Now, generally hydroelectric turbines work on this principle of converting mechanical energy into hydroelectric energy. As you can see, this is the rotating part of the turbine. This is known as the Francis turbine or the Francis impeller, and it is named after its creator, James K. Francis. James K. Francis. James K. Francis was an American engineer. Now, what generally happens in a commercially produced hydropower plant is that water which is stored at a high level in reservoirs in high quantity is generally naturally flowed from the bottom of the reservoir, and it is used to propel the turbine, which then produces electricity. Here I have used a tank which contains water, and inside this tank is a pump which gives the water a pressure of 1.7 bar, or we can call it it resembles water falling from a height of 17 meters. 17 meters. Now the water comes from this. The water is gushed out from this submersible pump into this, and this is a valve for controlling the pressure of the water. And then this valve, this pipe connects it to the water force jet, which then rotates the turbine. Now, this is the most important part of the turbine, and it is used in generation of electricity. This together is known as the alternator. The alternator has two parts: the stator and the rotor. This part is known as the rotor because it is the rotating part. Now the rotor has four fixed permanent magnets in its inner walls, and it rotates. This, as you can see with the copper wire, is known as the stator. The stator consists of wound insulated copper wire, and it is a conductor. Now what generally happens is when water passes and rotates this turbine, it causes this rotor to rotate, and the rotor rotates, inducting a voltage into this conductor. Now, how this happens is due to Faraday's law. What Michael Faraday stated was that when the magnetic flux of a magnet is changed due to rotatory or any other motion, a magnetic voltage, an electromotive force will be inducted into the conductor. We can simply call electromotive force as a voltage. Now this whole generator is capable of producing 12 volts of electricity. Now this 12 volts of electricity, I have connected to a step-up transformer. This step-up transformer has the capability to convert 12 volts of energy into 220 volts. What I have done is I have connected the wires which come from the generator to the primary winding of the transformer, and the output comes from the secondary winding of the transformer, and it is connected directly to the bulb and to the voltmeter to show the volts. Now I will show you a working procedure of this turbine. As you can see here, now the rotor will rotate when the water is gushed in. You can see that water comes in from here. The rotation of the turbine causes the alternator to rotate at high speeds, which then gives out a voltage of about 195 volts. This voltage is sufficient to light one bulb at its brightest peak or more than its brightest peak, and two bulbs with normal voltage. When one bulb is lit, there is still 150 volts remaining, and when two bulbs are lit, there is only 10 volts remaining. see, here on the inside you can see that only the rotor is moving while the stator is stationary inside the alternator.